this is your snack sandwich. Today I took a quick look at this shell protocol. Now it's a pretty complicated thing in some ways. The whole idea here is that it's supposed to be simpler. The system is simpler in that it's trying to build like a standardization for all DeFi protocols so that they can interact with each other and be more capital efficient. So if you see here, it says where simplicity meets DeFi, powerful one-click transactions, near unbeatable capital efficient AMAs, and modular developer experience. So the idea of this thing is that it's a single entity that allows all protocols to work together. I do have a flowchart for you to kind of explain how I understand it, but as always, I would suggest you come here, read this white paper. I did read through this white paper a few times. I still have some questions in my mind, but I think I have enough to explain kind of a introduction on how this thing works. And then if you want to know more, you could go in and read this paper yourself, go ask some more questions, dig a little deeper. So let's swing over to the flowchart and take a look at what I understand this thing does as of now. Okay. If you would like to support the channel, I would suggest you to check out the secretsandwich.xyz. It's the Secret Sandwich NFT project. You can come here, you can mint an NFT, or you can come and check out your NFTs. Okay, so let's get back to it. Okay, so here we are on the flowchart. We're going to start with Dollar Bill here on the left. He's got some USDC, and he wants to sell it he wants to buy some W or ST ETH. Okay, let's just say in this example. So this is the kind of the standard of how the Uniswap version 2 pools would work. So like any kind of AMA that uses Uniswap version 2 pools, this is kind of how things would work. Okay, so he would interact with what they call the router contract, and the router contract would then kind of do the math for him and decide, oh, what's the best way for him to get these tokens that he wants. So it's going to direct him through likely these 2 pools, assuming that there's no USDC WST ETH pool, then he would have to hop through these 2 pools. So his tokens would go through the router, hop through these pools, and come back down to him, and he would get his tokens. Now, the first thing I'm going to mention that this router is a contract deployed to the blockchain, and its job is to calculate kind of the tokens. It does the math and decides the route. That's why they call it a router. Okay, so it's a complicated contract per se, and it does have a lot of things that it needs to do. It needs to query. It spends a lot of gas. Let's put it that way. Okay, moving on. There's another thing to keep in mind, that every time you write something to the blockchain, it costs about 5,000 to 20,000 in gas. So just keep in mind that every time you write something, it costs more gas. So the idea of the shell protocol or the ocean shell protocol is to try to reduce the amount of gas spent to make things more simple, more efficient. So in order to do that, you have to reduce the amount of things that are getting written to the blockchain. So let's look at this example Dollar Bill it has here. So there's a whole bunch of token balances. Now I'm going to use balance of, but that's not really the function that's being called. I'm just using balance of to make it easier for you to understand. Okay, so when this swap happens, then on the blockchain, Dollar Bill's balance of USDC needs to be changed to 0 or whatever. Let's say he used all his USDC to buy, right? So his balance needs to be changed. The balance of this LP needs to be changed for USDC. The balance of this LP needs to be changed for ETH. And then again, the balance of this LP needs to be changed for WETH. The balance of this LP needs to be changed for STETH, and then Bill's balance of STETH has to be changed. So 1, 2, 3, 4, 5, 6 balance changes, as well as the router calculating and fetching data and stuff like that. Okay, so as you can see, it can cost is quite inefficient, right? But this is kind of how a lot of AMMs are working right now. Now we have Balancer. Balancer is an older protocol, but it fixes this issue quite well. Okay, so what they have done is they have, instead of having like separated liquidity pools, they have one big giant vault or liquidity pool with all of the tokens inside it. And as you can see, it clearly reduces the amount of writing. So, but they still have the router. The router still needs to do its calculations. It still needs to query the prices and stuff like that, and decide, you know, how to best handle this trade. Now, there's only 4 balances changes, so this heavily reduces it, especially in the case where there's there's not a direct route. So balance of, balance of, balance of, balance of. So 4 written writings to the blockchain as well as the calculations inside the router. Now, let's say Booster Bill, he thinks, oh, he's degen, he's got it better, right? So he uses a DEX aggregator like 1inch or Firebird or something like that. Now, what does 1inch or Firebird do? Well, he has to, again, there's a balance checks between him and 1inch, so he's going to have to change his balance as well as the balance of all of the pools that 1inch decides to interact with. Now 1inch and Firebird make up with this because they're giving you arbitrage opportunity. They're taking care of arbitrage of all of these pools, so they might be able to get you a better deal because of this case. But as you can see, like, it's interacting with all of them, so it's changing the balances of many pools as well as perhaps using the routers of these, depending on the algorithm that they're using. They might interact with a lot of things and change the balances of a lot of different locations of tokens, right? Moving on. Now, in addition to that, this is all done off-chain. So this calculation algorithm is done off-chain, and that's up to you to decide whether or not you feel that's a good thing or a bad thing, right? But it's pretty standard now, but at the same time, there is that trust factor in there that they are giving you the best opportunity, and there's no way to confirm that per se, right? Now, I'm not even getting into the idea of the balance changes and the writing and stuff of different things like, NFT trading, as well as lending and borrowing on things. Now I use Cream here because there's some whispers of Cream maybe coming back, but Cream or Aave or Compound or any other lending borrowing, there's the minting and burning of tokens as well as the balance changes of contracts, as well as creating liquidity pool on different AMMs will have this mint and burn function as well. Okay, so there's all these different functions that need to be called, and they all cost gas. They're all, generally speaking, writing to the storage on the blockchain, right? So in comes this shell. Now shell is a little bit different. So the first thing that I'm going to mention that shell is everything in shell is using the ERC 1155 standard. So it's an NFT kind of standard with a lot of metadata. It has more information than the ERC20 standard. Now what makes this special is that it can interact with everything then. Okay, it can use NFTs, it can interact with ERC20 tokens, it has all of the space or all of the necessary inputs or metadata to hold to account for everything. Now, if it's an ERC20 token, it will just have some fields that are considered still remaining empty. Okay, so that's the first thing, is everything inside this ocean is using this ERC 1155 standard. Now, let's go through a swap on Ocean for dollar bill here. It's quite similar to what we have down here, okay, in that he swaps one token for another token. All of the tokens are inside a single ledger, so this entire smart contract knows. It's very similar to what we have down here with Balancer. All of the tokens are in here, and he swaps in one, he gets out one. There's no multi-hop inside this situation, okay? However, where it gets special, let's take a look at the writing. Okay, so again, it has 4 writings, right? And inside the memory, it does a little swap inside the memory. So a memory thing does take some gas, but it's significantly less than writing, okay? So in this case, because it's just a simple swap for one token from the other, it's very similar to what we have with Balancer, except it doesn't have this other smart contract. It integrates these 2 contracts into one. Okay, so that's what kind of makes this special. Now remember, the ledger is all in ERC 115, so all of the tokens, whether they're NFTs or not, they'll all be inside this singular vault. Okay, so again, just four writings, and it's using the memory to do the swap instead of using some on-chain calculation as well. Moving on. Now let's say Grandma wants to buy an NFT, okay? Now I don't know who, in this case, we don't care who's selling that NFT, but that NFT person, seller, he wants USDC for his NFT, right? So Grandma has some W Bitcoin, and she wants to swap and she wants to get this NFT. So it works quite differently here, okay? So let's go through kind of what happens with her. Okay, it kind of works backwards because the NFT, the first thing it's going to do, it's going to basically take the NFT, right, and unmint this NFT. Let's say the seller has already listed it into Ocean, so it's already wrapped as an SH NFT. Okay, so now what it's going to do is first thing it's going to do is all in one kind of big transaction. It's not going to send it to her, but until everything's done. But it unwraps the NFT to her. So there's a writing of the balance of the NFT to the Ocean, and the balance of the NFT to Mom, and then it pays it does the swap from SHUSDC to the NFT to remove the NFT from the ledger, and now there's a SHUSDC that's owed per se to whoever was the seller of this NFT. When they can come and withdraw their USDC, and then Grandma's WBTC is the balances of Grandma's WBTC is changed. Ocean gets the WBTC, and the swap for USDC and WBTC can be fulfilled. Okay, so that's pretty much how this works. Now, I know it doesn't really explain it very, very clearly, but I think what the idea of this is not so much that like, oh, like what's the difference between Balancer? Why not just use Balancer instead of using this? The point is that all of these protocols, if they were to adopt this Ocean standard, they would all be inside of the single smart contract. Now that might be scary because it might be a honeypot. It might be like, ooh, pretty juicy for black hat hackers. However, the idea here is that like it's super capital efficient if everything's inside one contract, and you don't have to like interact with stuff. There's basically one transaction for Grandma, one transaction for Dollar Bill. Now, if you were to go the other way, let's say Grandma wanted to buy this from Blur, she had some WBTC, she would have to sell the WBTC in one of these AMAs, like maybe Balancer or Uniswap, maybe do multi-hop Uniswap to get her USDC, right? And then she would have to use the USDC to buy the NFT from Blur, and that would then create quite a bit of gas spent on her behalf, as well as multiple interactions with different protocols. Okay, so that's pretty much it. Like I said, dig deeper. Go ask some more questions. Join their Discord or whatever you can find. Read that white paper and see if you can understand this a little bit deeper than me. And I hope this has been useful and interesting. And I thank you so much for watching. And goodbye.